All right. This video is about the Pythagorean Theorem. We're going to do two things. Take a look at number 3 here in this sample problem. When we have a right triangle, we know it's right because we have the symbol here indicating a 90-degree angle. When we have a right triangle, what the Pythagorean Theorem allows us to do is it allows us to find one side that's missing. Notice in this case we have an unknown value here, but we do know, and we call this the hypotenuse, this longest side. The other two sides we call legs. They're the shorter sides, and they make up this 90-degree angle. So we know their lengths are 4 and 3, and we're not sure about this one. So the formula that we use for the Pythagorean Theorem looks like this. It says that if I take side A, and let's label these. So this will be side A, let this be side B. So if I take side A and square it, and I add to that side B, and I square it too, then those two squares added together are equal to side C also being squared. So the beauty of this is if I know sides A and B, I can figure out side C without a whole lot of issue. All right, so let's do that. So I know that side A is 3, so we'll put that in, so 3 squared, plus side B, all right, well that's 4 squared. And we still don't know this unknown side, this hypotenuse, so we'll just leave it as C squared. Okay? So I know 3 times 3 is 9. 4 times 4 is 16. We still don't know C squared yet. Add those together, 9 and 16. That gives us 25. Now, it's at this point that a lot of people have trouble. I don't care what C squared is. No, don't care. I want to figure out what is just plain old C. C all by itself, C to the first power. So I've got to get rid of this exponent of 2. In order to do that, I'll use its inverse. I'll take a square root. So again, if something's being squared, to undo it, I take a square root. So C squared, and I take the square root of that, is just C. All right, these undo each other. It's like the other never happened. Here, if I take the square root of 25, I get 5. So in this case, I know the distance that I'm missing here is 5 feet. All right? And we refer to this as an indirect measurement. Notice I never took a ruler out and actually measured this side. I didn't use a proportion to see, well, if this side's 4 feet and it's this long on the paper. We never did that. We used the measurements we already knew, plugged them into the theorem, or into the formula rather, for the Pythagorean theorem, and then worked out what we should get using a little algebra. Now, this one worked out pretty nice and neat. All of the side lengths, in this case 3, 4, and ultimately 5, are whole numbers, so we call that a Pythagorean triple. So anytime you get these nice whole numbers, it's easy. However, if we look at, say, this next example with number 6, a calculator is probably going to be your new best friend. A lot of these are not very pretty in terms of the square roots. Squaring those numbers aren't too bad, but finding your square root is going to be rather difficult. So let's work this one out. So again, we know that it's A squared plus B squared is C squared. All right. Let's label our sides again. Now notice, for the two legs, it really doesn't matter which one's A or B. If we look back at this last one, I made the lower side here A. In this case, I'm going to make this side A. So long as A and B are the two sides that make up the right angle, it really doesn't matter which is which. All right. So here we go. So A squared, that's 5 squared. We've got 3 squared here equals C squared. Now, a point of order. Let's look back at these two problems. A lot of people think that these two problems are exactly the same. That notice I've got 3, 4, 5. Notice 3, 5. Well, then this has to be 4. Remember, side C is the longest side of the triangle. Notice here I've got 3 and 4, and then the longest side, the hypotenuse, is 5 feet. Well, it's the longest side. Here, this can't possibly be 4. It wouldn't be the longest side. So in cases like this, even though the numbers look a lot alike, these are very different triangles. So we're going to have to be very careful with this. So let's work it out. We know what 5 squared is already. That's 25. And we just worked with 3 squared. That's 9. We'll go ahead and add these together and get 34 equals C squared. Now, if you didn't have a calculator, all right, remember, we have to take a square root, and in this case, 34 is not a perfect square. So we have a couple of options. If we're going to eyeball it, we can say, well, it's really close to 36. Square root of 36 is 6, so this has got to be some number less than 6. All right, that works. If we need to be a little bit more specific and a little bit more precise, then we'll probably need to break out a calculator. So in this case, I'll take the square root of 34, and we'll see what we get. Cool. So in this case, we've got 5.830951, blah, blah, blah. Who cares? According to the directions on this particular page, we were asked to round to the 3 decimal places here if necessary. Well, in this case, it's very much necessary. So let's see what we've got. So I know that side C is, well, let's rewrite that. It's not going to be equal to anything. It's going to be approximately. Right? Because I'm not going to take this exact value. It's irrational. It'll just keep going and going and going. I want to stop here at the 3rd decimal spot. So to do that, I need to go 1 spot over to C. It's a 9, which means I need to go up. So I'll have 5.831. So let's write that down. 5.831. So 5 and 831 thousandths, in this case, inches. And again, another point of order, if you were truly measuring in inches, odds are you aren't going to measure, number 1, to this level of precision, and number 2, inches aren't measured in a decimal format. So just heads up, you would have measured this in, say, fourths or eighths or 16ths, 32nds, whatever, 64ths if you want to get that, small. But again, for our purposes, we'll just use what we've got. Now, let's try one more. Let's try this this one here, number 8. Now, notice 28, 45. These are the legs. Wonderful. But notice the variable's changed. In this case, it says Z instead of C. So a lot of people get confused when they see this and say, well, hold on, wait a minute, that doesn't follow the formula. It's not A, B's, and C's anymore. Well, remember, A and B make up the legs. Inside C is simply the hypotenuse. So if a problem does this to you and you don't like the variable, in this case Z, fine, change it. We'll make it C again. All right. So again, how about this side being A this time and this side being B? All right, we can work through this. So A squared plus B squared is C squared. All right, let's see what happens. So we get 45 squared plus, what do we got here? 28 squared is C squared. Now again, if the numbers get too big, don't sit there and mess around with this. Take your calculator. There we go. Now we're back in focus. Take your calculator and just work it out. So I'm going to take 45 and square it. All right, so that's 2,025 plus. If I take 28 and square that, that's 784 equals C squared. We'll go ahead and add those two together for 2,809. Wonderful. And again, this is where a calculator comes in handy. Taking the square root of, say, 34, that's pretty easy to do in your head. Taking the square root of 2,809, most of us have no clue what the next closest square number would be. For all we know, that might be a perfect square number. So in cases like this, calculator be your best friend. So we'll take the square root of our 2,809. Let's see what we get. What do you know? This is a perfect square number. Its square root is 53. So we have another Pythagorean triple. And in this case, we're measuring in feet. So 53 feet. So there's the Pythagorean theorem in a nutshell. The formula that you'll use is a squared plus b squared equals c squared. Remember, a and b are the two short sides. C is the longest side, the hypotenuse. Plug in the numbers that you know, and you can find that hypotenuse relatively easily. All right. In a different video, we'll show you problems like, say, number 9 here, where notice the hypotenuse we already know. It's a leg measure that we're trying to find. So again, best of luck to you, and if you ever need help, swing by in the morning for morning help time. Thanks.